If you're a developer or architect, you know the importance of visual design artifacts such as sequence, system, or component diagrams. Mermaid is one of the scripting frameworks that's popular, and it allows embedding of technical diagrams inside Markdown files. Today, we're building an agent that will create Mermaid scripts and then convert the script into an image, save the image, and display it to the user. We'll use Smolagents from Hugging Face, a brand new agent framework that packs a serious punch. This is the second tutorial in the series AI in Action. More on that later, but now let's jump into the use case. It will start with the user providing a text prompt to the diagram agent. The agent will first generate a mermaid script and then save the image to the file system and display it to the user. For the image generation, we will use Python image library, PIL, inside a custom tool we'll create for our diagram agent. Gradio will be our web-based UI using the incredibly convenient one-liner Gradio wrapper from Smolagents. Before we dive in, let's look at the business case. Let's say we want to generate a simple sequence diagram of a login interaction. What options do we have? ChatGPT, other free commercial image generators? But oftentimes, what you get is something like this or this, and if you're less fortunate, you may even get something like this. But the problem goes beyond mermaids and fairies, and that's where AI in Action comes. AI in Action is a series designed to demonstrate the true potential of AI in real-world scenarios. In each video, we dive into a specific challenge, from automating customer service to optimizing operations, and show how to tackle it with cutting-edge AI technologies such as agents, chatbots, and RAG. But that is not a one-person operation. It counts on your active participation and contributions. Each week, we're collecting ideas submitted by the community, use cases, real-world problems, business cases, challenges, product ideas, anything that can be improved through AI. We're polling the community and letting the best ideas bubble up for the next video. Smolagents is a Python library designed to build agents. We have a tutorial on this channel about Smolagents, so please make sure to check it out. This is how simple it is to create an agent with Smolagents. Couple of lines of code and we get a fully functional code agent that uses web search tool to answer users' queries. How is Smolagents different than other frameworks? It brings the concept of multi-step agents, where at each step the LLM can write an action in the form of calls to external tools, and the agents perform code execution and self-healing. This is truly unique among agent frameworks, and it comes quite handy, as we'll see in the demos later in the tutorial. This diagram, also included in the GitHub repo, describes how the user interacts with the agent-based app running inside a Gradio web interface. Be sure to check out the code and run it for yourself and make some changes. Post in the comments what interesting changes you've made and the results they've produced. If you need support or just want to connect with like-minded AI developers, consider joining the Discord server. The link will also be in the video description. Okay, let's start our coding tutorial. As usual, we'll start with our imports at the top of our script. We're going to import datetime and OS, as well as from Smolagents, Code Agent, Light LLM Model, Tool, and Gradio UI. From Mermaid, we're going to import graph, and from PIL, we're going to import image. These are the libraries that we're going to use to generate the mermaid diagram and save it as an image to the file system. For our model, today we're going to rely on GPT-4o Mini. We're going to use Light LLM Model class from Smolagents. Light LLM Model allows you to use any model that you'd like, including local models. For the tool definition, we're going to use the tool directive and then a plain Python method. We're going to call our tool method mermaid render tool, and we're going to pass the mermaid string, and from that string, we're going to produce an image and save it to the file system. The top docstring defines the purpose of the method. This is important as the tool and the LLM and Smolagents determines the purpose of the tool by this docstring. So to ensure the best outcomes, this docstring must be descriptive and include the purpose as well as the arguments. These are important. Next, we're going to create a sequence as a graph, and we're going to get the timestamp and then pass the file path as the diagram underscore timestamp, so that in every iteration of our UI tool, we can save our image as a new diagram with timestamp. Next, we're going to use md.mermaid, passing the text, and then generating and using that 2PNG file and saving it to the file system. And next, we're going to read our image and pass it into image path. And finally, using PIL, we are going to return image.open with the image path. So at the end, our tool returns an image type. Okay, let's define our agent. The agent will be a code agent. If you're familiar with Smolagents, you would know that there are two types of agents. The first one is a code agent, that's their default agent type, and the second one is a tool calling agent. We're going to rely on code agent because of its self-healing abilities. It will create Python code, and it's a multi-step agent that will execute the code. And if there are any errors, then it will fix them and self-heal and execute again, as we will see in the later demo steps. The Gradio UI is an amazing one-liner from Smolagents where we can pass the agent and it will create the UI for us with the prompt and the results. So that's what we're going to use, Gradio UI, passing the agent and .launch. That's all we need to do. So that's our script. It's a very short script actually for the functionality that it does, only 32 lines of code. And once we save it, we can launch our Gradio UI script. Now we can do that with Python, one diagram and the name of the file, and that will launch our script. Once the script is running, it will create a URL and it will launch a web server for us. It will run on localhost port 7860 and the URL will be in the terminal. So you can click on that or just open it in a browser. So let's open this in our Brave web browser. And this is the Gradio UI interface that comes built in as a one-liner in Smolagents. On the bottom, you see the chat message, and in the middle, we will see the chat interactions between user and the agent. Let's start with our first question. Create a typical login interaction, and let's see what the tool comes up with. The first thing that it will do is it will go to the LLM and ask for a typical sequence diagram. The results will be returned as mermaid script. So here you will notice in the green type, this is the mermaid script returned by our LLM. This is step number 1. So we have the mermaid script already created. And by the way, there is an option. I didn't do it in this tutorial, but you can also save it as a mermaid script or embed it into a README file as well, because Markdown supports mermaid scripts and it's a very convenient way, and a lot of tutorials offer mermaid scripts right there inside the README file. But what we're going to do here is we're going to continue and pass this text into our agent, and our agent will take that and then create an image, save it to the file system. And if we wait a little bit, we will see it here too. One small parenthesis here. What you're seeing on the screen where it says error is quite normal. Do not be alarmed by that. This is how agents work. They do executing it in a couple of iterations. It's normal for the first or second to produce a number of Python errors. The agent then looks at the errors, auto fixes them and executes them. And typically within 90-95% of the time, you do end up getting the results that were requested. So that little error there is not a problem. You can just skip it and continue the execution, but you can also look at the details of the error message itself. I am sure in future releases, Smolagents will refine that and fewer errors will be displayed to the user, but it's actually a good idea to see where it stumbles and how it's able to fix it because of its multi-step nature. Okay, let's continue. And now we can see the sequence diagram generated. We can right click on it and open it in a new tab since it's an image. And this is the entire PNG image of the login sequence diagram. Let's quickly take a look at this. Because we didn't provide much information to our agent, we just asked for a typical login sequence diagram. And what does typical mean? It just made some assumptions that it's perhaps for a web interface, and we have a user, we have a login form, and we have an auth system. We haven't provided what kind of authentication we have, so it just put a box there called auth system. And that submits the credentials, returns the validation with valid credentials, and then a session is established. So it's a rather simple diagram, but it demonstrates the capabilities of our code. Back in Visual Studio Code, in the terminal, our scripts are running, and here you can inspect how Smolagents work and where the issues are and what the outcomes are. If you take a look, you will see the PIL.jpg image plugin kicked in and produced this picture into the file system. So the final answer is the diagram. Okay, Now, if we go and inspect our output folder, we'll close the terminal real quick here and click the diagram underscore the timestamp. You will also see the same image saved because we'd like this to be saved as well as displayed in the Gradio UI interface. One thing about Gradio is that as soon as you kill the process, you lose all the history and all the images there. So if you're not saving these during the generation process, all of this created work is lost. Unless, of course, you build persistent threads in your chatbot, these will be lost upon closing of the chatbot agent. So for that purpose, I would recommend after each interaction to save important assets that are being generated, such as the markdown script itself or the image file. So let's continue the tutorial. That's the image saved in a PNG format. Now back to the terminal, our script is still running. And now we can inspect the other logs here. So starts at the top. The agent first generates the mermaid script. You can actually copy and paste this to any online or offline mermaid editor or inside a README file, and it will render a proper mermaid script sequence diagram. You will likely get the same image embedded either into a README file or inside the online mermaid diagram. You will see in red the error. So here it produced a indentation error and then indicated which line the error is, unexpected indent. This is a typical Python file. This is the beauty of Smolagents, and that's what makes it different from other agent frameworks, is that it executes multi-steps in Python code. So it created the Python code, but the LLM is not always 100% accurate with the indentation. In Python, you know that the tabs and indentation makes a difference. In JavaScript or C-based languages, sometimes it's the commas or semicolons that matter, but in Python it's the indentation. So the LLM, because it sometimes returns text, the code is not properly formatted. Because of that, the indentations are wrong, and Smolagents executed in the first iterations understands that there's an indentation problem, fixes it, and then in the second iteration of the execution, everything works as expected. So that's what this tells us. Let's move on. Executing the code again, and now another issue, self-fixing the issue, and finally everything is fixed and we get our final answer. This is a great example of self-healing multi-step agent execution with Smolagents. Now let's go back to the Gradio and ask our second question. And for this, we'd like a variation of this login sequence. And let's see if we can add a little bit more detail into the login and ask for a typical e-commerce website with Shopify. So we'd like more modules and more boxes. Okay, so we provided more detail and we say using Shopify. Let's see what it comes up with. Okay, the results are in. We have a similar sequence here, starting with Shopify and authentication and browsing. We have a similar error, again, very likely indentation error. And now if we look at this sequence diagram, we will now see that we have the Shopify store in the middle, and then we have a payment gateway. So it's a different diagram, and it complies with the question, and it complies with the text that we provided. This shows a typical browsing experience by the user. Let's move on to our next question. We're going to ask this time for a similar experience, but by using the Okta as a login interface. And let's see how this changes the equation. Now we're adding more nodes into the sequence diagram because for authentication, now we're asking to add Okta. If we right click and inspect this diagram, we'll see that Okta is right there and the user is authenticated. Then it continues to browse the website and potentially go into the payment gateway. Okay, that's really interesting. Let's explore a couple other diagram types. Let's ask for a mind map and see how our mermaid generation tool will handle that. So here we're asking for a mind map, one of the diagrams supported by Mermaid. The mind map is already created. We can see the code. And let's see what the final image is going to look like. We asked for AI software development book outline and a writing process. So let's take a look at this brainstorming mind map. Okay, so we have our image. Let's go and take a look at the image. It's quite descriptive. there is a root element to the mind map, and from the root there's table of contents, there's chapter outlines, there are examples, there is trends and trade-offs. It's a pretty good outline for a brainstorm session on how to create content for AI developers. That's great. This is one of the other diagram types that are available as mermaid diagrams, and mind maps are supremely useful for various tasks, including in engineering, brainstorming, project management, analysis, and design. So very, very descriptive mind map that was created. Let's ask another question. In this example, we're going to be asking for a pie chart with certain data elements. Mermaid diagrams are also good for creating pie charts as long as the data is provided. So here we're just asking for a simple pie chart with 4 elements, and we're providing the percentages. This is a fictitious framework usage distribution pie chart. So let's see what it comes up with. Now, this part is interesting because it is also showing us that it's going to use matplotlib, a Python library, to calculate the percentages and the angles and the radius and all these different things, and it will produce the pie chart as a MATLAB plot and then include it into the diagram. So super interesting. Let's continue and see the output of this. Here we see how different labels and slices are created inside the Python code. This demonstrates Smolagents' ability to generate Python code, and it's so cool because with this ability you can actually create various content types, not just mermaid script, but you can create tables, you can use data frames, and you can use any other Python framework that is needed. The agent is smart enough to pull these frameworks and use them. Okay, let's inspect our pie chart. We have a bit of an error, which will be auto-fixed. That's okay. And now here's the pie chart. Let's right click and inspect our pie chart. It looks pretty good. AI tools distribution with 4 frameworks: LangGraph, CreoAI, Pydantic AI, and Smolagents. These numbers are fictitious. They do not represent the market share, but this is a good example to explore. And it's a pretty good quality and resolution. Next, let's explore another chart type, which is the Gantt chart. Our question will be a simple agile project Gantt chart with 6 iterations, and let's see what the tools will come up with. I'll be honest, the Gantt charts have been challenging for this model to create, and you're free to use other models, and I've used GPT-4o, which produces better results than this. But for some of these results, it's been challenging, but it does create a mermaid diagram code at least. Feel free to inspect the code, copy and paste it. What I'm going to do here is I'm going to paste it to an online mermaid editor and see how this Gantt chart looks just from the code generated. It looks okay. It's not the greatest Gantt chart. Gantt charts are tough. Sometimes they include too much information. That's why it's good to limit it, but just we're testing the boundaries of the capabilities of our agents, so why not? So this is what the Gantt chart looks like. It's 6 iterations, there are some tasks, and now let's see what our image looks like. We'll right click on it, open it, and it looks quite similar. The image generation part is not that different. The script is what makes it different. Okay, let's move on now. Our next example is a component diagram, and we're going to ask our model to represent AI taking over human jobs in a component diagram format. Let's see what this comes up with. Here's the mermaid diagram produced by this. Okay, we can again copy paste and inspect it in our online editor and see what it looks like. Let's make it a little bigger. And here we can see that AI is targeting manufacturing, customer service, transportation, healthcare, finance, and education jobs. And this is a component diagram representing the job displacement by AI. Interesting, just as another type of diagram that can be produced and that can be explored. Of course, for real world projects, you would probably pass a lot more information, but here's our image. It looks quite similar to the mermaid online image that was generated. We see the sectors, and we see healthcare, transportation, and we see the role of AI. We see robotics, chatbots, autonomous vehicles, AI diagnostics, algorithmic trading, e-learning platforms. Now let's move on to our next example. For our next example, we're going to ask for a state diagram. So we've covered sequence diagrams, we've covered mind maps, we've covered component diagrams. Let's take a look at a state diagram. And for this, Our question is the state of the EU economies as the regulation takes over. So let's see what our model comes up with. I chose these last two questions purposely unconventional just to challenge the model and see where the boundaries are. So this may not be a typical software engineering project, but let's just take a look at how the model handles it and what kind of diagram we receive. We're going to zoom in here and we're going to start with the state being at the top, and we start with stable economy. That's our first state in the state diagram. Then we're going to increased regulation, and then we're going to economic strain, and then reduced growth, then recession, and then crash. And after the crash, then it goes to end state. Of course, there is no recovery in this state diagram, but that's something that can be easily prompted. And again, this is just an example of us showing a unconventional question for a state diagram. Typical state diagrams usually apply for software applications, but why not? We can test this with any question and the LLM will produce a mermaid diagram. So pretty good diagram. Let's inspect ours. Should be fairly similar except the styling. And here we can see the states are also logged into our screen and our image is ready. Let's right click and open it. As expected, it looks fairly similar to what we've already seen. Now let's go back to Visual Studio Code, and in our output folder here, we have all the diagrams that are saved. So you can go and inspect each and every diagram. I will include these diagrams in the GitHub repo. If you just want to go and inspect a few diagrams, they will be there for your reference, but you can create your own as well. Let me know in the comments if you come up with more interesting ways to create mermaid diagrams for other creative uses. Mermaid is a very universal framework and it's a very convenient framework. It actually saved us from the tyranny of UML tools is what I call it. Back in the day, there used to be large UML packages that we were required to use as architects and software people. But nowadays, it's become a lot easier to just create a UML diagram and embed it into any artifact, including Markdown files, which makes them so much more portable. But of course, there are limitations to the Mermaid. It does not support the entire UML format, not by any stretch of the imagination. It's for 20-30% of the job, but still it does a pretty decent job of communicating ideas and intent. So I personally love the Mermaid format. If you come up with more interesting uses or applications, please chime in. Cool. So that's our output folder. And those are our images. Let's move on to a bonus example. This tutorial was only for mermaid diagrams, but in the process, I also created a different Gradio app that creates images. So I wanted to include this script also, although not part of the mermaid diagram. We're done with that. I just want to show you a quick way of how to generate your own images, everyday images that you may need to create for other purposes. Now, this tool does not generate diagrams. If you try to generate the sequence or login diagrams, you're going to get the examples that I showed you earlier. So the two are very different purposes. One is for mermaid diagram, technical diagrams mostly, and this one is for just any image that you'd like. I'll show you a couple examples of images that hopefully will be interesting for you to watch. Perhaps we'll give you some ideas how to extend this and make it even more interesting, because who doesn't need image generation? And this is one almost free way of how to generate images. I can tell you this, I've been using this with the GPT-4o mini model, and the cost for generating 100 images is about 2 cents, 1 to 2 cents for 100 images. So that's an incredibly low price, and the speed is relatively fast. And by the way, you're not stuck with OpenAI models. You can also use local models for image generation. If you have a strong GPU and you can use one of the good models, then you're good to go. I don't have a GPU, and that's why GPT-4o mini for me is a lifesaver. So let's go and take a look at the script. Again, we're going to use Smolagents for this, Code Agent, Light LLM model, and Gradio UI. Our model will be a Light LLM model passing GPT-4o mini and our API key. And now we're going to define an image generation tool. Load tool is a very convenient utility from Smolagents that you can load any tool from the hub. As long as it has its tool definition.json file, you can load this and use it. In this case, I'm using mrig text to image, which is one of the tools that uses image generation model to produce the image along with GPT-4o Mini. We're going to initialize the agent by passing this tool in the tools array and passing our model, and then we're just going to launch Gradio UI. 18 lines of code, and we have our own custom image generation. You can customize it with more styling. You can pass a system prompt and pass specific instructions. The style of the image is 3D, impressionist, whatever you like, but I just wanted to keep it simple for this example. So let's go and run this real quick. Let's open the integrated terminal inside Visual Studio and run with Python to image generation agent.py. It's going to launch our Gradio UI on the same port. And so we're going to go ahead and open this. Don't worry about those errors, by the way. They're just warnings. So open the same URL in your browser. And let's do that. I'm going to go back to my Brave browser. And here, let's enter our first prompt. This is the interface. And our first prompt will be to generate a cute puppy. So we enter this prompt and hit enter, and the model generates this. One of the things about this script is that every time, depending on the constraints and the runs, it will generate a different image. If you're not getting the result that you want, you may want to modify, because it has a little bit of caching, but you may modify the prompt and run it again, and you may get a better image if you're not satisfied with what you're seeing on the screen. For this particular one, I wanted a 3D Dalmatian, and what I got was this cartoonish looking puppy. I'll show you an example that I generated earlier. I saved it so that we can take a look at it now, and you can see the difference. Let's go ahead and look at the result that I had generated earlier. So this is the puppy that I generated using the very same prompt. There was nothing different, but two different runs of the tool can generate two completely different results based on busyness of the model and some of the errors that come along the way. This is a very high quality image, by the way. The resolution is over 1600 by 1600 square format, which gives you plenty of resolution to work with. I use these for my covers in other places. So this is a tool that I actually use personally every day. Let's move on and ask another question. Let's stay with puppies and ask for a puppy in a gondola in Venice. So let's see what it comes up with. And here we have our image. It's a very nice, very cute puppy. Let's take a look at it. High quality image, really good. It fits all the descriptions that I outlined. I wanted a 3D hyper realistic puppy wearing a beret and wearing a shirt with suspenders and a red tie inside a gondola in Venice. So this is the puppy that the model came up with. Really, really good detail, great image, simply amazing. I also want to show you the puppy that I had generated earlier. So I'll save this because it's such a nice puppy. But this is another example of the puppy. I was running this prior to the tutorial, and this is another example. The same prompt, two different executions, came up with these two different examples. Now let's go and try another prompt. This time I asked for a hedgehog in a hot air balloon wearing the same outfit as the puppies, and it came up with this cartoonish looking hedgehog, which is not what I wanted. It depends sometimes on the busyness of the model. You may get errors. Sometimes the model is too busy because it's pulling from Hugging Face, and so the results are not quite good. But if you try again or just modify the prompt very slightly, you may get a much better picture. So I'll show you what I had received earlier. So this is the hedgehog that I was looking for, and this is 3D high quality hedgehog, a character with all the properties that the prompt asked it for. Let's move on. For our final question, we're going to ask a question about cats in a Ferrari inside a tornado. So this is one of my favorite questions because it challenges the model and we can see what it's capable of. So this actually is quite good. We see a Ferrari. Not familiar with the model lines. I'm not sure which one it is, but it's convertible for sure. And we have 4 cats. There is a tornado in the background and flying cows. So it's very, very challenging generation example, but the model did quite well this time. It's 3D, hyper realistic, just as I asked it to. And here I'll also show you the image that I had generated prior to this run, so you can compare them because they are slightly different. So this is the image that I asked the model with the same prompt: crazy cats in a Ferrari inside a tornado and flying cows around them. So interesting outcomes. You can experiment with this. 18 lines of code and almost free, or if you plug in your local models, you get this for free. This is quite good for image generation, and it fits the purposes that I wanted. So hopefully you will appreciate this bonus example and you will use it for your needs as well. Let's move on. Okay, today we've demonstrated how small agents and AI-powered workflows can streamline software engineering tasks like diagram generation. By leveraging AI agents for the Mermaid script and the image generation, engineers can save valuable time and gain quick insights into complex systems. Whether you're a developer or an architect, this agentic flow provides a practical example of AI in action, ready to be adapted to various real-world scenarios. We've come to the end of this tutorial. If you've stayed this long, I'd like to thank you for your time and attention. I hope you enjoyed this video and you learned something new. If you like the new series, please consider subscribing to the channel and giving the video a thumbs up. If you have any feedback, please submit a comment. Thank you, and see you in the next one.